Hey, Donna. Let's wait for probably 2 more minutes. I think we have quite a lot of people here already. So today we want to continue on the BG pick discussion. So we will continue from the last time the discussion. How you want to sharing your slide and we can start the discussion.
Okay. Okay, let's continue this slide. This is the current entity support in FR. We can see there is an RTA NCID field to help to distribute a route with the NCID. And the RTM unit hop helps us to distribute the net hop information to the data plan by using an object-based approach. This is the route information stored in the kernel using the net hop aspiration method. We can see the route 2000:178 uses NHID 24077, and the net hop 24077 is a net hop group that includes two other members, the net hop 50 and the net hop 24078. So we want to modify the route distribution process to SONiC in a manner that is fully consistent with the kernel distribution. Additionally, we want to separate the pick information. Therefore, the final FDB format for extra distribution is shown in this slide. The first item demonstrates compatibility with the previous support scenarios. For example, for SONiC systems that do not use FR as the SONiC control plan, we will still use the original route distribution method. The second item demonstrates the use of underlay NH for route distribution. And the third item demonstrates a route with an underlay net hop group. The net hop ID for route 5555 is 7, which points to an net hop item with the net hop type as group. In the net hop table, the int with ID 7 contains two int members, 1 and 2. Similarly, the fourth, fifth, and the sixth items demonstrate the respective accounting scenarios for supporting SRv6, VPN, and SRTE. And the contents ID field refers to peak contents table, which is used to identify the seed information encapsulated when sending packets to the next hop. This is the forwarding table entry structure for the SRv6 side, based on the current Cisco Select 1 chip design. And on the next page, we will see the corresponding information between the modified routing table and the hardware. Here we can see the worth and prefix information from the route table corresponds to the side route information. The number 3 in the next hop table corresponds to L1 ECMP group. This ECMP group points to 2 NHIDs, and each NHID corresponds to an SRv6 type of next hop. Additionally, based on the context ID information in the route, we can find the tunnels encap mapper, which is used to determine the SRH encapsulation when sending packets through each SRv6 tunnel. So this is the current data structure design for routes in Zebra. The NHSRv6 label and VINI are stored in the next hop structure. We need to extract these fields and place it in the peak context table. The modified data structure design is shown in this slide. We want to extract the SRv6 NH label and VINI from the next hop and store them separately in the Zebra peak context table. Only the IP address is retained in the next hop structure. This way, we can ensure that when there is a next hop update, we can trigger the update of the next hop group to quickly refresh the table entries in the data plan. The reason we need to make this change is we want to maintain consistency between the table structure designed at the Zebra level and the hardware level. The reason too is if there are multi-route seeds coming from the same next hop, we do not want to create too many next hop members, as this could impact the conversion speed when the next hop changes. For example, in this scenario, we have 4 valves on P3, and each valve is assigned a different VPN seed. With the original implementation on P1, we would see 4 next hop members with the same next hop but different VPN seed. When there is an interruption on P3, P1 needs to refresh all 4 members before achieving complete traffic switchover. However, if we use the peak design, we only need to refresh 1 entry in the next hop group table to achieve the faster traffic switchover. So that's the reason we want to extract the seed information into peak context table from the next hop. Okay, that's all for PDB peak design. Any questions?
Hi, this is Kentaro. So for like additional attributes like content ID, are you planning to extend the netlink message?
Yes, we want to extract the all the information about the SRv6 and the labor.
Okay. Okay, thank you.
I think the PICs, we don't have the netlink message, right? We need to probably using the protobuf instead.
Yes, we should use the proto buffer to distribute that information.
Yeah.
For now.
For the NetHawk group, those things we have the message already defined, but for PICs, I don't think so. Yeah.
So are you using FPM or deep lane FPM network? I mean,
Yes, we want to use the deep line FPM.
Does VPlane FPM already have protobuf? I thought it's only for FPM. I might be wrong. But...
During the summer, the intern made the change, but haven't merged to the master. And right now, this one, we have separated channel. But I think the last time we say, hey, why using 2 socket? We probably for this project, we will combine them to be 1 socket. Basically, you can consider the protobuf is more like an extension if the netlink message is not available. This one will be similar to Kantara, what you proposed. Basically, we want to using the Zebra COI and the launching to enable the pick or disable the pick. Basically, pick will not be able to run at the runtime.
Sure. Yeah, I was just kind of thinking out loud that if there is any value of extending that link for pick, if this is only for FRR and SONiC, maybe we could just use protobuf, but
I think that's back to the previous question, is like, do we need to install those routes in the kernel or not? Yeah, because we do see that once we start to inserting a huge amount of routes into the kernel is not efficient.
I see.
So for these 2 million VPN routes, that's why previously in the one of the intern project, we want to skip the kernel insertion. So from that logic, we probably want to say, hey, for this one, protobuf probably is a good choice. But it's okay if someone say later on, say, hey, I want to, for small scale, I want to inserting it to the kernel, then adding the kernel support, then we can change in the format.
Okay, I understood the situation. Thank you.
And Donna and Jeff, do you guys have any comments?
I think I'd rather see the end code. I mean, we got a design here. Seems reasonable.
Okay.
Until then, it's kind of hard to say anything. I guess the one thing is that you can't. One thing that's not going to be allowed, from my perspective, is you cannot break existing SRv6 or EVPN behavior.
For the EVPN, I will probably keep as is. Don't, because
but you're not. You're changing. You're moving the VNI from the next talk group to that table, right? That's an EVPN concept, right?
I can go back to that slide. Oh, I see. You're right. Yeah, I think probably by mistake at this moment I don't thinking that the value for the changing the EVPN is huge because the number of routes and convergence nobody complains. So I will only focusing this one for the MPLS VPN or the SRv6 VPN for now. But if say for example like someone will feel like this is a good approach for the VNI, then we can change in the future. But architecture wise, it's okay. It's the same approach.
Yeah, but current SRv6 code works, right?
Yeah.
So
Yeah.
you can't break the Linux kernel version of that.
That's true. Yes.
And I guess the proof is in the pudding about how that communication is going to be sent down to the data plane.
Yeah. So SRv6 itself is in the global table, which don't have the PIX context. So I was not expecting the PIC will be used in the SRv6, but the SRv6 VPN will be one.
I don't understand what that means or what you're saying there.
So here the PIX context, what we store is the VPN context, which we learned through the BGP to identify which verb the remote site will pick. So that's for the VPN context. But for SRv6, it's
currently able to pass down SRv6 data.
Yeah. No, what I mean is like SRv6 and SRv6 VPN are two different features. SRv6 is global table.
Are they from Zebra's perspective? I don't think so.
Say for example, like for this approach, SRv6 pretty much will not be interchanged because there's no PIC context needed for the SRv6 alone.
I guess what I'm saying is that if we have two separate code paths for the same data that's slightly different, that's going to be a no-go from my perspective. Okay. Every single time in the past when I've had multiple code paths where slightly different case where we didn't take the time to abstract properly, it came back and bit me, and I'm not really terribly interested in going down that path again.
Okay. I think like the other one probably we can go a next level detail once we go to the HOD. Right.
Also, Eddie, if we assume that we also need to implement PIC for the global case, and maybe that's what we were just discussing, but eventually, I know this particular use case is specific for VPN, but if you need to implement PIC for global case, which I think will come, we need to make sure that the same design works there, right?
Okay. That's a fair point.
We don't want a different design for global BGP PIC and VPN BGP PIC.
Well, the global. Yeah, go ahead.
Very similar comment from my side. It addresses your use case, but PIC is in general needed, right? Even internet size table would benefit from indirection. So having different designs would defeat the purpose of the feature.
That's fair point. Yes, we could take care of the global table also. It's not a big deal.
It's a big deal in a way. You are pretty much the only user of SRv6 today. Everybody else is using BGP for different things, right? So, and probably EVPN would be the most interested consumer, right? We already have all variety of deployments with FRR with million+ routes. So let's make sure.
Yes, that's why I would say like for the VPN routes, I don't think it gets to the millions at this moment, right? I don't know if anyone see the million routes in the VPN context.
In the VPN case, for sure.
For the FRR case?
Yeah.
Okay. Then I will probably, like I say, facing in, like I say, for the VPN, we could, like, architecture-wising, we could say this is doable, but I need help if someone want to implement for the PICs to the EVPN, because we don't have a test resource for that. Because that one is that you get code ready, the other one is the test infrastructure. So my initial goal probably was still say, keep the VPN as is. Don't make it a change. If someone feel it's necessary, we can just enhance it. So I would rather face in.
I didn't get that comment, Eddie. Can you elaborate? What do you mean by keep VPN the same, unchanged?
No, I would say like because we could disable the PICs, right? So architecture-wise, we can say all the VPN or the global context we use the PICs approach. But for testing or the releasing point of view, we were facing them out. So I will probably start with the SRv6 VPN first. Then, depending on the use case, then we can add in the VPN in the future. But we need to make sure the architecture-wise, the code can be handled. Then, once we finish those code, the people just need to add additional change on top of it and make the testing effort.
Are you referring to the EVPN model versus
Yes.
SRv6 VPN model?
Yes, yes.
Yeah, I mean, the test part we can phase in, right? But I thought the discussion is about not just the test part, but also the implementation, the design piece. As long as we ensure that there's commonality between that, yeah, testing can definitely be phased in. That's a second. It's an important, but that's a orthogonal problem, right?
Yes.
So I guess the question is, from a design standpoint, what's being proposed here, does it work for the EVPN case as well? And the global case. I think we need to make sure that all those three cases work seamlessly for BGP PIC support using a common design, right?
I think this, based on the previously my experience in Cisco, it should work, right? Because basically the context for the PICs is opaque to any of those features. It just say, I will get some remote context. You're organizing those contexts in a different way. That's the main goal for the PICs.
That's probably true.
Because previously yeah, go ahead.
Okay, no, so what I'm saying is, I think in this particular picture, if I look at it, right, I mean, the PIC specific context is added in the case of VRF. Are you implying that for the global case, we would use a similar model, but extend the global tables as well to kind of have it's like, if I look at this picture and take it at its face value, the PIC context is associated with a VRF construct. Whereas the global context doesn't have these, like at least the way the data structures are shown on this slide, right?
Yeah.
So how does that, I guess the question is, for global, are you proposing that we still create a Zebra VRF context and with a special VRF ID and we use the same model, or are we going to extend the global data structures also to include the PIC construct?
So, how you can go back to the original data structure? Yeah. So currently, like this is a part of NetHop, right? We didn't put any PIC table in the VRF context. So now we want to move out this red part and have a separate object in the Zebra. So then the benefit is like now we can share in the NetHop. Then once we share in NetHop, it doesn't really matter it's on the global table or it's on the VRF table, because logically it's the same. the question is like, should we using the structure of the zebra verb or there's another zebra global structure? I don't know, but that probably we need to investigate a little bit to see how the global table get handled. But logically will be the similar. You moving these field from the next hop to the common location where you could do the search for the context table. So you manage it independently with the next hop. Yeah. So
I guess what you're saying is the intent is to kind of share the next hop, right? That's why you're removing the prefix specific context from the next hop.
Yes.
And placing it prefix or VPN specific context from the next hop and placing it in a higher level object, so that the next hops can be shared. So that's a fair design pattern, but putting that into a VRF context would also work as long as there is a global table equivalent of it.
Yeah.
And what my point is, I think that has to be part of the design, even if the actual testing is phased in.
Sure, that's fair point. We probably can put this into the HLD. Mm-hmm.
So another point to note here is, Eddie, that whatever construct we are using here, it will boil down to the similar construct in the site. Is that correct?
Yes. So right now, if you see that we iron out the site mapping for the SRVC VPN, for the global table, those things, we probably need some extra help from you also, like I say, to introducing the recursive route handling. Because global table will need the recursive routes. Right now, the site doesn't have it.
Yeah. Yeah, I think we need to, we were saying that, we will talk about the site changes. Maybe it is better to understand that as well before we make this conclusion, right? Because if we look at EVPN, we cannot separate out the label from the next hop. I mean, that is the basic premise here, that you have to separate out the label from the next hop. So it may not be a generic design that fits all of the overlay models.
But Hassan, which label are you referring to? Label associated with the next hop or label associated with some other object?
Label slash VNI. So so label is, in case of EVPN, you can say like, the VNI or the MPLS label for that particular, which is associated with that next hop.
Which is associated with that. Okay. If the label is associated with the next hop, then technically that should be VPN independent, right? If that next hop is shared across multiple, I mean, if that next hop itself is shared across multiple contexts, then wouldn't the label be common across all the contexts, or are you referring to the label being specific to that VNI, the pair of VNI and next hop?
So, okay, so see, it's like this. If it is overlay next hop, the overlay next hop will have the next hop egress information as well as the egress rewrite, which is the label which you have to slap before you send out the frame.
Yeah, right.
Right. And what I'm saying is that, these two things go hand in hand.
That is true. If it's an overlay next hop, yes, the overlay next hop and the label that for the rewrite that goes with that next hop. So that's given.
Yes.
But are you implying that overlay next hop? So obviously, I think the overlay next hop may be common across multiple, but you're saying that in this case, the overlay next hop is specific to that VNI.
Correct.
Okay.
So
got it.
With this model, I think what we are trying to achieve is that the egress may be the same, but the rewrite information may be different for say different VNIs. And in that case, we want to actually separate these out, that independently I can update the the label information in the next hop is a big context,
Correct. Exactly. Yeah.
which does not fit the existing model the way the existing SCI APIs for EVPN have been designed.
That is true. We'll have to pull the label information out of the next hop and have that associated with some other context, right? Maybe a VNI common next hop ID context or something like that, so that you decouple the actual next hop from the label associated in the context of that VNI.
Exactly, which is actually a big change right now. And we cannot, in this small forum, cannot make the decision.
Correct. Yeah, agreed.
So let me understand a little bit. In the VNI case, your next hop is not a BGP next hop, but on the tenant case. So
you're asking that how the overlay next hop for EVPN looks like?
Yeah, the overlay next hop, I thought this is also the BGP next hop. You're saying this is the overlay next hop is different from the BGP next hop.
So yeah, so overlay next hop is a combination of the BGP next hop and the overlay.
Yes.
The label information. Yes.
But then, so the BGP next hop itself, it's a shareable, right? It's the BGP context, which is in the global table, right? That will be your VXLAN, like the tunnel information, right?
Correct. So the way this is being achieved right now, it's actually using the two-level next hop. So yes. So
when you say two-level, you mean like you have the VXLAN NH, right, which will give you the encapsulation, which have the BGP next hop information. Then you resolving it through the IGP next hop, right?
Correct.
Then it will be similar to what the VPN case, right? We separate the context. Basically, your BGP next hop is potentially shareable, right? For the remote PE, you could have multiple VNIs, but the BGP next hop itself is shareable, right? But just the VNI we put in the PIX context, which will not share, right? I just say from logical point of view.
Yeah, I think you're right. I mean, conceptually, you're right that the level 1 next hop information is actually nothing but the label, which has to point to the level 2 next hop.
Yeah.
And
but level 1 point to the level 2 is different from here, right? We are right now in the more say the BGP next hop is level 1, right?
Sure.
And for the EVPN, the SCI API anyway, we allowed to say creating the next hop, but then the SCI internally resolving it for the level 2, right? We don't need to create a forwarding chain to say level 1 over the level 2. It's basically inside of the SCI, right?
Right.
Kind
exactly.
Of yeah,
exactly.
It's similar to the SRv6 NH. SRNH, we also say we created the tunnel, then it will be the level 1, then it will be resolved through the level 2, but it will be done by internal in the SCI.
Yeah. So, but then if this requires changing the existing SCI APIs, then we need to actually go to the SUG as well, right?
No, this one doesn't need to change existing SCI APIs. For the EVPN case, I will say we can reuse the same, because here we use the SRv6 NH. In the EVPN case, this is the VTAP NH. Only the venue probably will be stored somewhere else. We need to see what's going on. I haven't looking at that part, but logically it will be like that. What I'm more interested in is like for the global table, for the recursive routes, let's say BGP global table over the IGP. Today we clapping them into FR. That one, I want to see that can we add the side changes to making this recursive natively supported.
Okay. Yeah, let me also do some homework and then I can update.
Okay, yeah. Because I feel like if we do that, we can improve in the convergence for the recursive routes case.
So for SRv6, you're proposing a new set of Psi APIs?
No, we reusing the existing Psi API. So all the API, so that's why you see that currently Hanyu mapping the existing data structure to the existing Psi API. So
Okay.
the PIX context it's in the in-cap mapper. That's where the PIX context is stored in the real hardware.
Okay. Yeah.
So for the SRv6, I don't need any extra. So I think that for SRv, at least I don't need anything extra from side point of view. But the only thing I would say that for the global table, for the recursive routes, we may want to see that can we support it natively, basically let the level 1 over level 2 directly. Instead of today, we collapsing them into the FR, well, in the FPM, basically, where we sending down to the awk agent.
Yeah, Zebra itself is actually doing the recursive resolution and sending the next hop.
Yeah, but today, like that's why I would say, like today we were clapping them into one level. I want to see that if we take the Kantara's next hop group approach, ideally I could get a level 1, level 2 set independently, but level 1 will have dependency with the level 2. That one
Yep.
I need the side change.
Yeah, but
Because
then
today,
for overlay,
yeah.
then you need 3 levels, right?
Well, overlay, no, that depends, right? That really depends on like how you handling it.
Yeah, I mean, think of like you have, say, EVPN running over BGP, where the BGP next hop is resolved over OSPF.
But the BGP next hop over the OSPF, it's flat, not recursive, right? It's normally that will be your OSPF route, right? Because it's a loopback address from the PE, right? Remote PE.
Yeah, but then I did not get when we say that, global next hop itself can be broken down into 2 levels. What did you mean there?
No, global it's more like say last time, like say the Microsoft T2 issue, and also Alibaba also see the similar issue is like say we have like a 16 like recursive routes over the 16 passes. Then we get to 256 passes. For that particular case, I was thinking we could do like say just 2 levels. So don't clapping, or let the hardware make a decision to decide if you need clapping or not. There's no need to let the FPM to clapping them.
Yeah, which also is same as actually the example which I was taking, right? That the BGP or UPN over BGP over OSPF. This is exactly same as what you're also referring.
Okay, I see your point. So basically, say the BGP next hop is a recursive route.
Correct.
Okay,
Correct.
yes, yeah, that's fair point. Yeah.
Yeah, then you need 3 levels.
Then this is 3 levels. Then yeah, you're right. But normally, like I say, because normally for the MPLS VPN, your BGP next hop normally will be distributed through the OSPF, and normally it's not recursive, right? You could let's say for example create a static route over then redistribute it to make that recursive.
Yeah, but if you get into those situations which you were highlighting, where the underlay next hop itself is actually recursively resolved, then isn't that you need 3 levels in that case?
then in that case, you could say like say how if I would say this most likely will be the OC agent, right? Depending on hardware capability. Can they support it in the 3 level in the hardware without performance penalty, or they have to do the 2 levels? Right. So my point is like say this decision can be done in the OC agent or somewhere we get to know the or even inside the site, underneath the site where we know the hardware chip capability.
Yeah, but then you're right. I mean, I think we need more thoughts on it. It will be a bigger change, and we also need to weigh in the benefits which we might be achieving because of this, breaking down the 2 levels. Because if I think in the previous review, Kentoro's review as well, we were debating whether Zebra, if it reacts to this next hop change, it might still be actually pretty late, and the traffic might still be getting impacted. So the decision has to be closer, even closer than Zebra actually. So even if we have broken down this, I mean, I understand that SIV6 has a specific use case, and it might make sense to actually to do what you are suggesting here. But for the existing underlay and say VPN, I'm not sure.
Yeah. I will say this way, like we probably want to making this the data structure change common, which we can extend for other features like the EVPN or global table. But for the initial implementation, we probably will just say we only do the SRv6. Then we could take a look at the global table, because I feel like global table is something we probably need to address also. Especially in the data center, like right now, we do see a lot of global table usage. So recursive routes can help in the convergence.
Yeah, I think if it all is with Donald and the FR community, whether they like actually having 2 separate paths.
So okay, so you're saying like there could be the 2 passes. Okay.
Yeah, let me get back on the VPN, because I was saying that we already have actually 2 level of next hops. If the moment we bring in say Kentoro's changes, we will have 2 level of next hops for EVPN already being pushed by FRR. The top level is gonna be next hop group. The second level is actually that will have the VNIs, and then internally the last level, which is the egress next hop, the underlay next hop, that is resolved internally by the SI. So
I thought the EVPN only have 2 levels, right? Why you have 3 levels?
Yeah, exactly. So it does not have 3 levels, but if you see from the next hop group point of view, you have you already have actually 2 levels, right? The top level next hop group has 2 single path members. I mean, multiple single path members. And
I see.
yeah. So
but for Kentaro's one, that is kind of opaque, right? We can continue using his code with the current FPM approach, is collapsing them into one. Right. Today we collapsing already. So no matter how many level you have in the following chain, FPM only give one level out for the IGP NH. We can then with this assumption, then container code can still work. Then we can continue to see that should we breaking that recursive to say native support. Then we probably need to check, say, for the Broadcom chip, like say, if we have like a 2 level in the IGP, then have one more level in the EVPM, would that helps? Do you see any performance penalty? But sometimes you do, sometimes you don't. So that's why probably you need help to see that would that be possible.
Yeah, I would say we can take it offline. I mean,
sure.
I can actually discuss this more closely with you if you're okay.
Sure. Yeah, sure, definitely. Yeah. So any other comments?
Can you go back to the data structure after enabling BGP PIC slide? So I guess one thing I'd like to see some design on is the D-plane messages surrounding the Zebra PIC context table. And I don't mean the FPM changes. I mean how you plan to send the data down to the data plane through the data plane pthread. Because I want some thought there. I don't think we kind of waved our hands a little bit. I like to have some thought there about what that data structure will look like.
Yeah, right now we haven't go deep on that. Do you have any suggestion? Like I say, if we wanted the protobuf, this pretty much will be the union.
This is long before protobuf, right? Right. So Zebra abstracts talking to the data plane through the D plane, Zebra dplane.c, and we have a context that passes the data down as an individual piece of data. I'd like to see some thought around that. That
context will be the union, right? So it could be like say different the VPN context. So say for example, like we listed like 3 groups, right? 4 groups, right?
And the second thing I'd like to see some thought about that I don't, we kind of alluded this as well, is that, when we go to a global table and have a PIC table, a global PIC table for plain old SRv6, plain old MPLS, plain old whatever, how will we pass that data down if we've abstracted out all the data into that table?
Okay, we probably need to investigate a little bit to see.
I'd like just to have a little understanding, and I think it would help you solidify where you're going long term with this as well, because Linux kernel, if you've abstracted out the label, right? How am I going to pass the label down as part of that Nextop group installation?
Because today Linux kernel doesn't support the PICs, so which means that when we passing down to the Linux, we still need to flapping them.
So yeah, like I said, the Zebra should not be tied necessarily to the Linux kernel, just as it shouldn't be tied to the SONiC SAI implementation. So if we need to make copies of data on the D-plane side of the pass down PIC table, so we can build the proper Nextop data structure, I'm not too opposed to that, but it just needs to be thought about.
Sure. My initial thought is like, but we probably can go deeper and create a point out the data structure. Maybe we'll put it in the HOD for more detailed information. So.
Yeah, I just need to think about how to handle this in the case where, you know, and this isn't just the Linux kernel. We're talking to FreeBSD as well too, right? So, and FreeBSD has some ideas about labels as well, and how do we handle that? And right now we play games, and I'm not sure playing games is the right thing to do or how to properly do it, but we need to think about that.
Last time when I talked to Hanyu, I say like because right now Linux is supporting the PIX context, so we basically say when we passing down the information, we need to do the lookup based on the context ID from the basically then combine the next hop and the context together with the currently next hop structures which go to the kernel.
Yeah, that doesn't change my statement. Is you know, looking at this, you know, I like I said, I don't want to have, you know, like I can add labels with is and things that aren't BGP and add labels to routes independently already, right? With just basic MPLS operations. And like I said, I don't want to have, oh, in some cases, MPLS goes this code path, and when we're doing this other type of special label, it goes this other code path. That's just untenable from a long-term programmability, from my perspective. Yeah,
I agree.
And so, like with this current setup here, there's no, I have no way to, I don't see an easy way to look up the label that I've added to a particular next hop for a particular route. And maybe it's just as simple that the route entry needs to point to back to the correct context ID for the, you know, the route entry should point to the next hop hash entry as well as the context entry that is associated with.
Basically, for each route, you have the context ID. That context ID will help you to do the lookup in this table to find out the associated PIX context.
It's not listed on, like I said, it's not listed on this thing here. There's, you know,
Okay,
we have the route entry points to the next hop group hash entry, but it doesn't point to the context ID associated with the PIC context table.
Yeah, you're right. Yeah, we could add that's a part of the leaf context.
And is it a PIC context table per verf, or should I have a global? And you know, maybe it needs, you know, because we do need to have a global one as well. Is there some way that I can keep the context ID that allows me to point to the appropriate table, and I can just figure out what table that I'm talking about based off the context ID? I don't know, spitball in there, but that sort of thing needs to be thought about as well. Because I could do route leaking across verfs.
Yes. I think for the global probably it's not that bad. So because the context ID, right now we're using the context ID to associate the VPN context with the routes. It doesn't really matter. It's in the global table or verf table. So as long as we assign the context ID like kind of uniquely for everyone.
Why do we really need a PIC table per verf? Just can we have one PIC table? Does it matter?
It doesn't matter. Yeah, I think we could combine them to be one table. It's not necessary to be per verf.
Yeah. And the other thing is I'm a little, why doesn't the PIC table point at the next hop group hash entry?
You could. Basically you say like I will have a pointer to have the picks pointing back to the next hop, which is associated.
Yeah, I'm not sure I fully understand why we went to having the next hop group hash entry to reduce the millions of next hops in the system, and we're putting them back with the pick table. That doesn't make a whole lot of sense to me.
No, the main purpose for this one is for the fast convergence. So if you have the BGP routes go down, you can have one place to update the next hop group, and then BGP reconverge, you can update the context accordingly. So that's the main purpose for the BGP picks.
Yeah, but why couldn't I just point at the correct next hop group hash entry?
You mean like for the for the routes, we're pointing to the picks table, then pointing to the next hop table, right?
And the pick table will have point to the next hop group hash entry. It's keeping a pointer to.
Yeah. That's fine. That's just more like the optimization, right? But logically, it's like as of today, we have the context information is stored as part of the next hop table. That's why we cannot share in those next hops. The moment like we separate the picks, making them as a leaf attribute, then you have a pointer go there. It's just the optimization, right? But the goal is like we only want to create one shareable like next hop, which if anything up and down, we can pass in that event to the hardware to achieve the fast conversion.
Okay.
And just to keep in mind, I think at least what I've seen before, this pick context table, this pick entry, that could also be shared, right? There could be many prefixes all with the same remote bids, like if it's per verse. So there's an opportunity for sharing, and then it's not one-to-one.
Yes, that's true.
It doesn't have to be that way, but it's possible.
It's really dependent on it's a per verb or per CE, right? If per verb per CE will definitely shareable, but if the per prefix, then you cannot.
Right, and the shareability is not for pick reasons, it's just for memory saving. That'd be about it.
Yes, exactly. Because the BGP will publish the same information. There's really no need to create the same information one by one. Good. Thanks, Mike. Yeah. So any other comments? And Don, do you need me to present this one to the FR community?
Sure. Once you get a little, get a little further on, that'd be fine.
Okay, maybe like when will be every month, right? I mean, the first week, is that the way we present, or?
No, someone goes, Donald, I want to talk about this. I go, that's great. How about next week?
Okay. I'm in China right now. Maybe once I'm back to US.
Okay. Let me know.
Okay, cool. Thanks. Okay. Any other comments? If not, then we'll continue on this path and create the detailed HLD. Then we probably start the HLD review. Yeah. Okay. Okay, then that's all for today. Yeah, thanks everyone.
Thanks,
Okay,
everyone.
bye.
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 Thanks.
Bye.
Bye, guys.